Algebra 2, 2-2, linear relations and functions. All right, let's look at linear equations and nonlinear equations. So let's look at the difference between these two. So here's an example of a linear equation. 4x minus 5y equals 16. X equals 10. Y equals negative 2/3 x minus 1. Y equals 1/2 x. Y equals 4. These are all examples of linear functions. Let's look at some non-examples here, or some examples of nonlinear equations. And let's see what the difference is. So 2x plus 6y squared equals negative 25. So we can see here we have y squared. We know if there's something squared, it's nonlinear. Y equals the square root of x plus 2. I've got a radical. It's not going to be linear. X plus xy equals negative 5/8. I've got an x multiplied by y. That's not going to work. This is not a linear equation. And y equals 1 over x. You can see how this looks pretty similar to the y equals 1/2 x, but if x is in the denominator, we're not going to have a linear function. So is it linear? Is it a linear function? And when we ask this, really what we're asking is, can it be written in slope-intercept form, y equals mx plus b? Can it be written this way? All of these up here can be. We can do some algebra to make this look like y equals mx plus b. This one we can write that way. We can write all of these in this form. This one is a little bit tricky, but it's okay. Y equals mx plus b, this one's already in it. So is this one. Y equals mx plus 0 would be your b value. So here we go. Example. Oh, actually, did I say this was a function? This is not a function. This is a linear equation, not a function. Okay. So here are our linear and nonlinear equations. Now we're going to look at these functions. So here's an example of a function. So f of x equals 8 minus 3/4 x. Is this a linear equation? Let me just rewrite this for you here. Let's plug in y for f of x, and then let's move this negative 3/4 x over here, and then add this 8 over here. Look, here I am. Y equals mx plus b. Yes, this is a linear function. How about this one? F of x equals 2 over x. Now I can do all kinds of stuff here. Y equals 2 over x. I can multiply x by each side. Xy equals 2. I'm going to have this problem. I'm not going to be able to get the x and the y separated here in the right way. No, this is not a linear function. Just like this is not a linear equation. This is not a linear function because the x is in the denominator in that way. Now here is standard form of a linear equation. And we use the standard form when we want to use the intercepts to graph the equation. Graph the line. So standard form is ax plus by equals c, and no fractions. None of these get to be fractions. Now if a is greater than or equal to 0, or is it positive? Then this is standard form. Then we're okay. This has to be, a has to be positive, or at least it has to be 0. 0 or positive, and we're okay. All right, so we are going to do an example of changing to a standard form. Let's do an example. I've got -3/10 x equals 8y minus 15. So I am going to change this to standard form. So I need ax plus by, and this can be minus, it's fine, but this is the standard form, equals c. I need to not have any fractions either. So first what I want to do is I want to get my x and then my y and then my equals and then my c. So I'm going to subtract 8y from each side. What I do to one side I do to the other. So -3/10 x minus 8y equals -15. Okay, now this a value needs to be positive and it needs to not be a fraction. So I'm going to multiply everything by -10 to get that -10 out of there. So this will be positive. So I'm multiplying what I do to the left, I do also to the right. So I just drew it like this. So I'm going to multiply everything by -10. So -10 goes here. So that means I have 3x. -10 times -8 is going to get me positive 80y equals -10 times -15 is positive 150. Now I have written this in standard form. Now, I'm going to show you real quick. Well, no, actually, let's just go ahead and do a u-try. So 2y equals 4x plus 5. Use your knowledge of algebra to change this to standard form. Pause now. Okay, let's see how you did. I need the x to be on the left plus the 2y equals c. So I'm going to subtract 4x from both sides, and I end up with -4x plus 2y equals 5. Now this a value needs to not be negative, so I'm going to multiply everything by -1, and I get positive 4x minus 2y equals -5. And so now my a value is 4, my b value is -2, and my c value is -5. Now, one thing I'd like to show is how do I use these intercepts to graph a line. So now we've changed our equation to standard form. So let me just say, okay, here is standard form of an equation, 2x minus 3y equals -12. So here's how to use this standard form to graph a line. All I do is I make a t-table, and I say when I plug in 0, I get a number, and when I plug in 0 for y, I get my x value. So I plug in 0 for x. So when I plug in 0 for x, I get to just ignore that because 2 times 0 is 0. And then I say negative 3, y equals 12. So negative 3y equals 12, divide by negative 3, y equals negative 4. So when x is 0, y is negative 4. X is 0, y is negative 4. 1, 2, 3, 4. There it is. And, oh wait. Oh, negative 12. Positive 4. 1, 2, 3, 4. There we go. Because I've got negative 3 and negative 12. So this is negative 12. Positive 4. Okay, great. That was a close one. Ignore that one. Now, when I plug in 0 for y, I can ignore this part of the equation because negative 3 times 0 is 0. So now I've just got 2x equals negative 12. Divide by 2, x equals negative 6. So when x is negative 6, 1, 2, 3, 4, 5, 6, y is 0. Those are my intercepts. 0, positive 4, that's my y-intercept. And negative 6, 0, that's my x-intercept. And so there's my line. Now my y-intercept is when x is 0. My x-intercept is when y is 0. My domain and my range. Domain, all my x values from negative to positive, positive infinity, negative infinity to positive infinity. And my range goes all the way negative to infinity, all the way positive infinity, positive and negative infinity. All right, we got a little bit more to go here. I'm going to have you graph and identify the x and y and x intercepts. So on this one before, my x-intercept is right here. So my x-intercept is negative 6, 0. My y-intercept is right here. Y-intercept, that's the one that crosses the y-axis. So that's my x value is 0, my y value is 4. All right, so you do this one. 2x plus 5y equals 10. So graph it, give me my x and my y intercepts, and then we'll come back and do this together. Go ahead and pause now. All right, let's see how you did. So I want to find my x-intercept and my y-intercept, and I'm going to graph this. When x is 0, then let's do a t-table just to make this clear. When x is 0 and y is 0. So when x is 0, that goes away. I'm going to divide both sides by 5 to get my y value. So divide by 5 divided by 5. 10 divided by 5 is 2. So when x is 0, y is 2. When y is 0, then I've got 2x equals 10. Divide both sides by 2. 10 divided by 2 is 5. So I've got these 2 points. 1, 2, 3, 4, 5, 0. That's this one here, 5, 0, and 0, 2, 1, 2. There we go. And I can graph this guy just by connecting those 2 dots, trying to connect those 2 dots. Arrows on both ends, make that dot a little bit bigger so that it crosses the line. And there's my line. I've graphed it, my x and my y intercepts. So my x-intercept is here at 5. And so we can say my x-intercept is 5, or we can also say my x-intercept is 5, 0. My y-intercept is 2. That's where the line crosses the y-axis. Or I can also say 0, 2. And that is all she wrote for lesson 2-2.